Page 7, number 32. Read it and then come back. Now, a marathon race in Utica, New York requires competitors to run around 3 city landmarks, the theater, bank, and hibachi restaurant, a total of 3 times. Now, think about what's happening. These marathon runners are going around 3 times. So times 3. Oftentimes we forget that if we don't write it in the beginning. So these marathon runners are going around these 3 objects. Now think about what these 3 objects are actually forming. These 3 objects are forming a triangle because they're like 3 points of your triangle. So what I want you to do on your paper is I want you to grab a ruler and very neatly connect all 3. Okay. You'll see your triangle now. The key thing in that sentence, that first sentence, is they said that the runners go around the 3 landmarks. I mean, it makes sense. They're going around the landmarks. But that word around should clue you into what you have to do in this question, and that's perimeter. Anytime you see something going around an object, a polygon or a circle, if you're going around, you're thinking perimeter. You're thinking circumference, okay? Going around something. Maybe you're tying a bow around something. Maybe you're tying all 3 of these landmarks together with caution tape. But if you're going around, think perimeter. Okay, let's see what they tell us about these 3 landmarks. They're telling us the location of the 3 landmarks, -6, 7, 8, 2, and -2, -7. Each unit represents a mile. And how many miles is the race is your ask. How many miles is the total race? Don't forget, you're going to have to multiply by 3 because the runners go around all 3 landmarks 3 times. Your final answer needs to be rounded to the nearest 10th. Okay, so the question is, well, how are you going to get the length of the entire race at least once? Not all 3 times, but let's start with just getting the length around all 3 once. Now, what does that mean? That means that you want to get this length, and this length, and then this length. Well, to get lengths on a graph, you could either do distance formula, but that gets tricky, and you have to make sure you do that formula correctly. Or the easier way, the visual way, is Pythagorean theorem. So what I'm going to do is for each one of these sides of the triangle, I'm going to create its own little right triangle to use Pythagorean theorem. So watch. For example, here between the theater and the bank, I'm going to create a little right triangle. It's actually not going to be that little. And now I could use Pythagorean theorem if I count the length of these 2 blue sides. So I've already done that. And you should be doing that on your paper. And horizontally, I counted 14 boxes. Vertically, I counted 5 boxes. So that doesn't look like a very good 5. Let me fix that. 5 boxes. So now I'm going to use Pythagorean theorem with 14 and 5 as A and B. And I'm going to solve for the length of this distance here and call that C, because it's across from the right angle. So here I go. 14 squared plus 5 squared equals C squared. 14 squared is 196 plus 25 equals C squared. Add those together, we get 221 for C squared. But I want regular C. I just want the length, not the length squared. So to get rid of the square, I square root both sides. The square and the square root cancel out. So square root of 221 is C. I'm going to keep it exact because I know that at the end I'm going to have to add all these numbers together. And if I start rounding now by putting it into my calculator, because I know that's not a perfect square, I'm going to get further and further from the correct answer. So just to prove it to you, 221 square root, that's a pretty long number. I'm not writing all those down, but I want to keep it exact. So 221 square rooted is the best way to keep it for now. Okay, moving on. Next one, I'm going to draw a little right triangle for the piggy bank and the diner, hibachi restaurant. Okay, here we go. I'm going to count up these lengths as well. Horizontally, we have 10. Vertically, we have 9. Go ahead and use the Pythagorean theorem. You should be trying this by yourselves. Okay, so 181 equals c squared. Taking the square root of both sides so that I can cancel out the square above the c. And now I have square root of 181 is equal to my c value. And that's exact. I have one more. You should be doing this one by yourself completely. So I took a quick little shortcut at the end there and skipped a step. So square root of 212 is my c value. Now, what I need to do is to figure out, well, what is all three of these lengths added together so that I know how long one time around the 3 city landmarks will give me. Okay, so I'm going to take the square root of 221, the square root of 181, and the square root of 212 and add them all together. Give myself some space to write. Okay, so my goal, I want to figure out what the length is one time around, and then I multiply that by 3 for the entire marathon. Now, I'm going to write down square root of 221 plus square root of 181 plus square root of 212. That's the distance around all 3 landmarks. At the end, I multiply by 3. Let's go to the calculator. Watch as I type it in, because you have the same type of calculator format here as you're going to have on your EOC. 221 square root. That's correct. Plus 181 square root. Notice the calculator shows me what the square root of 181 is first. I'm happy with that, so I click equals. So far I've only added 2 lengths together. Now the third one. Plus 212 square root. Yes, that's what the square root of 212 is. Hit equals. Okay, so all 3 lengths together are 42.8799, yada yada. All 3 of those make up about 43 miles. But that's not even the length of the marathon yet. The marathon is 3 times around. So multiply that by 3. Times 3. And you get 128.6397 yada yada. They want you to round to the nearest 10th. So to the nearest 10th, it's 128.6 miles. And we're done with this question. Just keep in mind, anytime you're asked to find the length of something around, whether it be a length of rope, a length of string, a length of caution tape, or a length of a marathon in this case, if you're going around something, you're going along the outside, the outline, then you're talking perimeter. Get the lengths of the sides, add them together. 33. A circle has a center at -3, 2. The diameter has coordinates of 5, 6, and x, comma, y. What is the value of y? Okay, I'm going to try and draw a fancy circle, so bear with me. Okay, it works. All right, now, this circle has a center at -3, 2. So I'm going to put a point, and we're at -3, comma 2. the diameter, which goes through the center, okay, so your diameter always passes through the center. It's a quick sketch. Has coordinates of 5, 6, and the other one is missing. So we have one endpoint that they gave us. It's 5, 6, and the other endpoint's missing. It's x, y. The question is, what is the value of y? Well, this is a question where we're given the midpoint, we're given one endpoint, and we have to solve for the other endpoint. I like to go about it visually when I solve for the other endpoint. And this is how I do it. I stack the two coordinates that I have with the midpoint in the middle. I stack them up. So it's going to look like this. 5, 6, my endpoint. My midpoint goes in the middle. -3, 2. And then my other endpoint, that's what I need to solve for. Now, since it's the midpoint, what happens above the midpoint and below the midpoint should be the same. So what I'm going to do is I'm going to figure out how do I get from 5 to -3 on the number line. To get from 5 to -3, I have to subtract 8. So I'm going to repeat that on the other side. -3 minus 8 gives me -11. Let's do it again for the y's. To get from 6 to 2, I'm subtracting 4. Repeat that again. 2 minus 4 is -2. So the question is, what is the value of y? The value of y is just -2. Now, I recommend you grabbing a piece of graph paper, especially on the EOC, and graphing all 3 points and checking, are they collinear? Are they in line with each other? And does it look like this point M, -3, 2, does it look like it's in the center? If it does, you're probably good. But if it doesn't, go back to the drawing board and try again. All right, let's move on. Number 34. The endpoints of two segments are given. State whether the segments are congruent. Now, if things are congruent, they have the same length. So this is a roundabout way of them asking for you to find the length of KL and the length of MN, and then seeing if they're the same. Now, when you have coordinates and they ask you for length, the best way to do it is Pythagorean theorem. I'm feeling a little lazy. I don't want to grab a piece of graph paper, so I'm going to show you a quick little trick that I use when I don't really feel like taking out a piece of graph paper. But you can always take out graph paper, plot these points, draw your right triangle, and use the Pythagorean theorem. So let's start with KL. Now with KL, I'm going to take a look at the two coordinates and I'm going to stack them just like I did before. And just like I did with the previous question, I'm going to think, how do I get from -5 to -12? I had to have been subtracting, and the amount that I subtracted is 7. I'm going to do the same thing with the 12. To get from 12 to 8, I subtracted 4. Now, I'm not trying to find the other endpoint here. I'm trying to find the length of KL. What you do once you've figured out what the distance is between these points from -5 to -12 and from 12 to 8, you're going to grab the numbers. Just don't care about the negatives. Just grab the whole number piece, the 7 and the 4, and those are going to turn out to be your A and your B when you do Pythagorean theorem. So I'm going to do 7 squared plus 4 squared, and that's going to give me C squared. I'm going to be fancy, and I'm going to call it KL squared, the length of KL, which is your C squared. 49 plus 16 equals KL squared. Add those together, you get 65 equals KL squared. Square root both sides. So square root of 65 equals KL. This is a non-calculator question, so I'm not turning to my calculator. Let's go to MN. Let's do this one more time. MN. Grab the two coordinates. -3, -2. 1, -9, and I'm going to look at how I get from the top coordinates to the bottom coordinates. So to get from -3 to 1, I'm definitely adding. I'm adding 4. To get from -2 to -9, it's going to get smaller, so I'm subtracting. I'm subtracting 7. You're going to grab those two numbers, the 4 and the 7, ignore the negative, and you're going to use it with the Pythagorean theorem as your A and your B value. So now I have 4 squared plus 7 squared equals mn squared. Now you should note, if I'm using the same numbers as I did before, 7 and 4, 7 and 4, I'm going to get the same length of square root of 65. Now I'm going to go ahead and finish it off, but just know I should get the same thing. So 16 plus 49 equals mn squared. Add them together. We get 65 equals mn squared. Square root both sides. And now we have square root of 65 equals mn. I don't need my calculator to see that these two lengths are going to give me the same thing. Square root of 65 and square root of 65. These two line segments are going to be congruent. They have the same length. So my answer to this question is yes, the two are congruent. So yes. In fact, I'll be even fancier and say KL is congruent to MN. Super fancy. Let's move on. Number 35, calculator question. The two triangles are similar. So you're thinking proportions, proportions, proportions. So the two triangles are similar with a scale factor of 5 to 6. What is the value of x? Pretty straightforward similarity question. You're going to use your scale factor when you set up your proportion, because all you're given is one pair of sides. So you have to use a scale factor in your proportion. 5 is the smaller one, so I'm going to match that up with A. 6 is the larger one, so I'm going to match that up with triangle B. And let's go ahead and set up our proportion. 5 over 6, which is my scale factor, is equal. Let's keep it matchy-matchy. So if I used 5, I have to do 3x plus 11. And then 6 comes from the same triangle as the 42. Okay, we're going to cross, multiply, and solve. 5 times 42 in the calculator. We get 210 equals 6 times the entire expression, 3x plus 11. 6 parentheses, 3x plus 11. Now, I don't like to distribute. I prefer to just get rid of that 6 outside of the parentheses. So I'm going to divide both sides by 6. So these cancel. So in the calculator, divided by 6 equals, I get 35 equals 3x plus 11. I'm going to subtract 11. $24 equals 3x. Divide both sides by 3. And now we have 8 equals x, or x equals 8. And we're done. Let's move on. Number 36, still a calculator question. Triangle SRT is similar, that symbol means similar, to triangle CBD. Now before we move on, let's go ahead and see how that matches up our side lengths. SR is in the first and second position. I'm going to give it a circle. CB is what it matches up to because it's also in the first and second position. Next, we have ST in the diagram that also has a length of 70. S and T are in the first and third position. So that should match with C and D. CD is the 50. Okay, so I've matched all the side lengths up. Find the value of x and identify the scale factor that maps triangle CBD onto triangle SRT. Okay, so it's a two-part question. First, it says find the value of x. So I'm going to use proportions, proportions, proportions. But part two of this question is identify the scale factor that's going to map one triangle onto another. So when we're talking about actually moving one triangle and turning it into another triangle, we're talking more about dilations or transformations. So when we're talking about mapping something onto something else, we're talking about dilations. With our dilations, when we want to figure out what our scale factor is, how much we have to grow or shrink something, we use something called K equals new over old. A new length over an old length. A new coordinate over an old coordinate. New over old. Now, in this case, they said that they want triangle CBD to map onto SRT. So they want CBD to turn into triangle SRT. So all I need to do is pick one pair of sides where I have the lengths, there's no x value, and put them in this fraction new over old. So I'm going to use the 50 and the 70. It's my only choice right now. So 50 and 70. My new is the 70. My old is the 50. So let me put that into a fraction. 70 is the new. 50 is the old length. Simplify that by dividing by 10. Those zeros will cancel. So K is 7 over 5. Now, what does that mean? That means that I can multiply my side length of 50 or this missing side length of BD or even BC by a scale factor. I'm going to put a little times symbol here. By a scale factor of 7 over 5, and it will turn into the new length. So BD will turn into RT by being multiplied by 7 over 5. And it's going to grow a little bit because 7 over 5 is a scale factor larger than 1. Okay, so we did the second part of this question. Our K value, our scale factor, is 7 over 5. And that will turn the bottom triangle into the top triangle. Or in other words, map it. That's another word they use, map it onto that top triangle. Now let's focus on finding the value of x. So to do that, we're going to do proportions, proportions, proportions. Let's start setting up our proportion. So we have 70, which matches up with 50. And then we have the 11x minus 4, which matches with 60. Make sure you keep things matchy-matchy. If you're talking about the new triangle as your numerator, so you have 70 up top, don't all of a sudden throw a length from the old triangle, the bottom triangle, as the next numerator. Okay? Keep it all consistent. So 70 over 50 equals 11x minus 4 over 60. Let's cross multiply. 70 times 60, 4,200. So 4,200 equals 50 times 11x minus 4. Protect the 11x minus 4. Put it in parentheses. And now again, I don't distribute. I like to divide out the 50 if I can. It makes things a lot quicker. So I'm going to divide out the 50. So we have 84 equals, these 50s canceled, 11x minus 4. So I'm going to add 4 to both sides. 84 plus 4 is 88, which equals 11x. Divide by 11, and now x is going to equal 8. And we're done. X is 8. That completes page 7.